So Griffon was working with different types of bulbs. He had made one specific type of bulb related to the radiant matter, radiant energy patent, following what was written, to the letter. He didn't take any tricks. He even made it look a lot like the bulb that Tesla had presented in the pictures. And he noticed that when he was hitting it with the Tesla coil and studying it, he noticed that radiation phosphor screen that was in the back of the room was lighting up a little bit, a little bit of a green glow. Of course, the next thing he does is while the bulb is in operation, he is holding the screen up in front of him. He holds his hand in front of the screen, and lo and behold, he sees his bones. And so he knows instantly that there's something that's being emitted by that bulb that is not conventional in any way. All of Griffon's tubes have one electrode, one wire. If you ask a physicist or ChatGPT or whatever, X-ray tubes always have two electrodes. There are no monopolar X-ray tubes. If there are, Griffon made a great discovery just by that sheer fact alone. Or actually Tesla did. He just replicated it 100 years later. If these were X-rays, if these were conventional X-rays, you would have radiation burns, you would have like hair falling out. Nothing would survive that. It would be completely sterilized. The cloud chamber, when we had the radiant his radiant bulb on it, it just completely overwhelmed. So we couldn't really tell what it was. It was our apparatus basically.
It completely overwhelmed, as in just light was shooting out everywhere?
Well, no, the cloud chamber just completely ionized the whole thing. Something's happening. Somehow you're able to get from 500,000 volts to 30 million volts. There's something that's stepping that up by a factor of like 20 or 30 to 1. One of the theories I have is that it may actually be the Farnsworth fusor. Is that what may actually be happening is there's some type of fusion-like effect happening on the electrode or on the surface of the glass, and that effect is causing this electron to be amplified or accelerated beyond what's normally coming out of it. The readings were along the lines of 5 or 10,000 chest X-rays a minute. Like,
yikes!
Like huge. Like you're talking. This thing's putting out 5-10 sieverts, which if anybody knows is like Madame Curie would be jealous. Our initial reaction, especially when getting some of the Geiger readings and some of the range experiments, was extreme paranoia, because if these are X-rays, then he's not going to live long enough to publish his results.
The Shadowgraph was a phenomenon of electromagnetism first discovered by Nikola Tesla, but it was almost lost to time. His notes lay mostly forgotten and unreplicated, except for a few curious minds who dared to work with them. And today, we're going to hear about one such individual, Griffon Brock. He decided to open them up and put the pieces together, rediscovering a lost technology at only 16 years old. Let's explore a story of old notebooks being dusted off, forgotten experiments being tested once more, and the possibly dangerous consequences of unleashing a forgotten type of light ray or particle ray. He works with a technique that has gone completely overlooked by modern electrical engineering, the one-wire transmission. The person I'm speaking with today was right alongside Griffon through this whole journey, so stick around and hear this incredible tale of high-powered electrons, X-ray-like frequencies, and maybe even nuclear fusion happening in a glass bulb in Griffon's basement or garage, or somewhere, wherever he was working. It's a tale that's still unfolding to this day. Thank you for joining us on the very first episode of a new podcast. We have so much more ground to cover in the future, so please subscribe and tell me down in the comments what you would like to hear about next. I'm Tommy Cleveland, and without any further ado, here's my conversation with Mr. Haka Says.
It's weird science and freaking magic.
So, do you want to get into talking about Griffin Brock?
Oh, oh, that was a good side project though. Yeah. So Griffin, we initially met at one of the energy science technology conferences, the Aaron Murakami's ESTC conferences a few years back. And between myself, Eric Dollar, Griffin Brock, and Adrian Marsh, we all sort of clicked. We were all working on the same high voltage fringe Tesla stuff. And it turns out that my commute is not that bad from Griffin, so we ended up doing a lot of collabs back and forth, working with each other. Our first meetup, I believe, our first collab project was I have more of an engineering, mechanical, techie, geeky background. So our first agreement was basically I would help make him a glass blowing lathe, out of aluminum and cheap chucks and whatever. It was relatively cheap and simple compared to the $5,000 things you buy online. So, I made it for maybe, $80 in materials and put a little stepper motor that helps rotate, and you can set the dial so it spins it, so it's a nice little glass blowing lathe. And I gave that to him in return for that. He had taught himself glass blowing, and he was making me some bulbs to play around with that. So that was our first mesh when we started working together.
Oh, that's
Is
cool.
I made him a glass blowing lathe, and he made me some cool Tesla. At the time, it was the carbon brush filament bulbs. It was
Uh-huh.
a evacuated bulb, and it had a little bead of carbon in the middle. And what it was is when you hit it with high voltage AC, high frequency RF AC, the carbon heats up and glows and incandesces. So it's basically an old school. It's an incandescent bulb, but because it's just heating up carbon, but it's doing it in a very unique way because using using Tesla high voltage to light up the bulb instead of conventional currents like a
Interesting.
incandescent.
Tesla high voltage, does that have anything to do with one wire?
Yeah, that's one wire. That was the difference. Griffin was going, Griffin's very old school, a lot like Eric is. The joke is they were both born in the 19th century.
Uh-huh.
So he
No, I can
wasn't he
tell.
he wasn't going through he wasn't going to follow the forums and the chats and the people that, claim to know better. He went back to the original sources, and he was reading, you know, Nikola Tesla's notes because he specifically says, well, it's like, oh, I did this with this vacuum and this material and this XYZ, and it had this result. So he went back to basics, and I guess part of that is he had to teach himself glass blowing in that process.
That's
But
incredible.
yeah, so that's where he got started, or at least started with this little micro community that we have going. Griffin, he taught himself glass blowing. I gave him the lathe. He did a lot of refinements and experimentation, trying to find out how to seal the bulbs. There's a whole art to glass blowing, temperature and composition, and it's very, very esoteric. It's kind of like if you learn how to weld or solder or things like that. There's a trick to it, and only practice will get you to figure out that trick.
Interesting. Oh man, what was I gonna ask? Oh, so I'm familiar with Eric Dollard's name, obviously. Griffin Brock, yourself, and then who was there was one other person you mentioned there?
This was Adrian Marsh.
Okay.
He's a gentleman from the UK. He showed up. First time I met him indirectly was 2019. This was when we did um, this was the 1/20th scale model Colorado Springs experiment. This is the one where they
Oh,
had the two big coils that were across the room, and he had the bulb, and you could see the null zone between the two coils.
uh-huh.
You could see where it was picking up AM radio stations and things like that.
Wow.
There was some, we'll say, equipment issues and politics after the demonstration, because what it was going to be is they had all this cool equipment and all the stuff, and they were going to do some cool high level experiments. But some of the equipment disappeared. We'll say the person that brought them left. So Eric wasn't really happy about that. But what ended up happening is Adrian Marsh is an RF engineer geek type. He's in that field, and we're all working on the same type of thing. So Adrian actually helped kind of save the day by working with Aaron to find out that, oh, it turns out the MWO, the multi-wave oscillator, the power supply for that uh, is almost perfectly matched to those Colorado Springs transmitters that they had, sitting in the next room. So it
Interesting.
turns out, so Adrian helped not only do some characterization and get some raw data, vector network analysis, and the raw bits of how that's made, but he also helped integrate using the MWO power supply with the Colorado Springs coils, and we were able to do some really interesting experiments there, following. Basically, it was a follow up on some of Eric's old Borderland videos, where you
Okay.
would have an incandescent bulb, but the bulb it wasn't lit like a filament. It wasn't the red yellow heat that comes from a bulb normally. It was really amazing, and a lot of it didn't show up on video. But with the MWO power supply, uh, instead of that color, what you would get is these little white, pure white needles that would be emitted from the filament in every direction. And then eventually, when they turn the power higher and higher, those needles turn into like a cloud
Wow.
inside the bulb, and the whole thing lights up with this very white light. And
So I mentioned that I'm kind of new to this whole world of fringe. I don't want to call it fringe
This
as an
was this was
insult,
the
but
2019, and this was one of the first like really fringe experiments that I personally was able to feel and touch.
that's interesting. There's just so many rabbit holes. I'm as a new person, I don't even know where to start. This all sounds like really interesting stuff. So where does that bring us back to the Griffin Brock story?
Well, yeah, I guess this goes back. Adrian Marsh, Griffon, whatever, myself, we got into this little community. Griffin had taught himself glass blowing. He was making a lot of Tesla replica bulbs, basically going through the original notes, printed out, this made with this vacuum or this gas, experimenting, mercury vapor bulbs and, different things like that. I guess one of the bulbs that he was working on was part of the radiant matter or radiant energy experiments.
Okay.
And what he told me is that, he had made one of these bulbs, and what it was is it didn't have any special gases. Uh, it was a bulb that was a very deep vacuum on it, and it had an aluminum electrode on the end, and that was it. It was nothing fancy. It was basically empty.
Mm-hmm.
And he said that when he put it on one of his Tesla coils, this was the diathermy machine, an old school Tesla coil. So
Okay.
he put it on the machine and he was experimenting, see what color emissions and how the frequency affects it, all these things. And I guess he said what he noticed is that in the back of the shop, he had one of those green radiation intensifying screens. And
Hmm.
he said that when he had the coil in operation, I think it was at night, he said he could see a little bit of, a little green coming from the intensifying screen.
Wow.
I don't know if you saw, the old Looney Tunes ones where they'll have the big black screen and it'll light up green. These intensifying screens. They're
Huh.
phosphor. So when they get hit with X-rays, they light up green. He happened to have some because it was other experiments and they're just cool to have.
Interesting. I wonder if that
So
influences the decision of the whole. I don't know if you've ever played a Fallout video game, but the black and green, Pip Boy color scheme and all that.
that was the old cathode ray TVs.
Oh, okay.
Not the because green turned out to be it's a really cheap and ubiquitous phosphor. So it turned
Okay.
out it's not only good for making, X-ray screens, it's also good for making TV screens.
Hmm.
So
Can
a lot
I,
of old, yeah, go ahead.
since we've been doing rabbit trails and hopefully those are welcome, can I say something about phosphors? You know how your regular screens you look at every day are blue light. It's been down converted into red and green to get a balanced white by the phosphors that they paint onto the LEDs. That's at least my understanding. I'm an art teacher, and
Okay.
I was looking for, like a really nice, what you call high CRI type of light that,
Okay.
you can paint, then you take your painting out in the sunlight and it looks the same. A very common experience for people painting is that, you get you're painting a color, and then you're doing it in your basement at 2 a.m. because it's due the next day or whatever. And then you take it out
Interesting.
in the sunlight. I literally had a color theory project. The entire classroom laughed at me, and the professor goes, "Are you colorblind?" And so since then, I had this thing
I've
like,
heard about that. That's interesting.
yeah. So it's just the spectrum that your bulb puts out. Um, is it can look white to your eyes, but the sensation of color is, wherever the peak is, or if there are multiple peaks within the spectrum of the light
Hmm.
that together even out to white. Your brain shows you white, even though you're not looking at a full, sunlight
Right.
style. Anyways, everything you're talking about as you're going through bulbs leads me to think about, what kind of discoveries are there to be made in terms of converting one color of light to another using phosphors. And what makes me mad is that we are all staring at these harmful blue light screens all day, but that problem has been solved. They have these things called triphosphor LEDs that put out violet light and convert down to a sort of blue with a phosphor and to a
Hmm.
red and to a green. And it doesn't have that huge blue spike, yet the technology has not made its way into everyday use. So sorry, that's my little rant for the day.
Oh, that's interesting. And well, I think the simple reason is there's not enough demand, and there's not enough demand because there's not enough education would be my guess.
Not enough
Same
people
reason
caring about their eyesight.
why do people eat so much garbage all the time? Some of the stuff that has, more ingredients than a science experiment,
Guilty.
people shovel it in all the time. I mean,
Yep.
once in a while we all go through that.
Yep.
But yeah, it would be interesting because it's like all these little subjects. These are entire lifetime projects that someone could dedicate time to and study and more fully integrate.
Yep.
Different
So
type of LED screen that has a pure white monitor. It's like, yeah, that would be pretty groundbreaking.
it would be very healthy, and it would not disrupt your melatonin, because I think your body is cued to sunrise and sunset. And so blue light does something to your system. Anyways, and I think it does, because the spectra is not perfect. It gives you a little bit of UV, which degrades your retinas. There's all kinds of
Mm,
problems associated with it.
I gotcha. But
Sorry. So
that was phosphors. That was the radiation screens are green, and the old like there's a lot of old TV CRT computer monitors that are green phosphor because I guess it's easier to coat that. I can't remember what it was, calcium something. At any rate, but it's a
yeah, I
cheap
think
phosphor, and that's why you see it everywhere. That Fallout green color.
I'm just young enough to not have had our first computer that my dad set up in our basement was it was black and white, no green. But
Actual black and white. Nice.
yeah, it was just,
Now,
DOS. You
what was common at that time is it was before the CGA, before the black, white, cyan, and magenta. It was usually either black and green or black and orange, like black and amber,
Wow, I've
and
never seen a
yellow in
black and
color.
orange. That's cool.
Uh, but anyway, yes, back to Griffon. So Griffin was working with different types of bulbs. He had made one specific type of bulb related to the radiant matter, radiant energy patent, following what was written, to the letter. He didn't take any tricks. He even made it look a lot like the bulb that Tesla had presented in the pictures. And he noticed that when he was hitting it with the Tesla coil and studying it, he noticed that radiation phosphor screen that was in the back of the room was lighting up a little bit, a little bit of a green glow. So
So
his step,
I'm
so
so sorry to keep interrupting you. I just want to make sure I'm following along. Hitting a bulb with a Tesla coil is synonymous
thing one
to one
wire,
wire.
he had it's
Okay.
a Tesla coil, and he had the top electrode attached to the bulb. So it was being energized with high frequency RF from that coil. So it's a one
Interesting.
wire transmission.
This is all new
Good,
to
good
me.
clarifier.
Believe it
It's
or not,
common with what we do.
I
If you see the cosmic, what is it? The plasma speaker is a one wire emission that's like that. And
okay.
some of the cosmic induction stuff is uses the same thing. But usually it's using a Tesla coil or some type of coil to bump the voltage and power up. So there's more energy that gets delivered into the end.
There's another rabbit hole to go down. I've seen that word, cosmic induction generator. I don't even
We'll
know
have that
anything about it.
conversation next time.
Let's go. I mean,
But
even Tesla
high
coils, I don't even, to full disclosure, I don't exactly know how a Tesla coil works. So, yeah.
on the lowest level, it's just a transformer.
Okay.
It's there's a transformer. All it really does is turn, low voltage high current into high voltage low current. A
And a
Tesla coil does
transformer.
that for AC at a very high frequency in a very efficient manner.
Okay. So, a transformer, I've seen them and I'm just intuitively, kind of applying what I know. Got a big, thick wire wrapped around in a coil. And then over top of it, you have a very thin wire. So we run electricity through the thick wire, and then that causes an equivalent magnetic electromagnet to be sort of induced in the coil above. And so you have, because you can run a lot. Oh
Maybe let
gosh.
me give you a better analogy.
Okay.
So, historically, the way we would explain electrical engineering is it would use what was called the hydraulic analogy or the water analogy. It's that electricity is basically like water. So
Hmm.
when you have a battery has a certain voltage and current. A flowing stream has a certain pressure and current. Current is the same word. It's meant for flow.
Right.
Uh, the analogy when we're working with a transformer is we're able to turn let's say, a large, slow moving stream into a very small, fast moving stream.
Hmm.
If you ever use what would be an example? Pressure washer. A
Right.
pressure washer might take 30 psi in one side and transforms it into a smaller amount of water at a much higher velocity and pressure.
So it is the flow equivalent of putting a tiny little pinhole on the end of a hose. And the way it's done is through a pair of coils, right? And then there's a, am I mistaken about that?
Hmm. How do we wrap that analogy into it? It's as if you had two different turbines. Let's say you had the Mississippi River or something like that, and you had a giant water wheel on one side, and on the other side, let's say you had a bunch of gears, and on the other end of all those gears, there was another wheel or another turbine. So this Mississippi River that's flowing at, let's say, 2 meters per second or whatever amount, that goes through all this gearing that causes it to spin up faster. So there might be on the other end, there might be this thing spinning at 2000 RPM.
Okay.
And that 2000 RPM can obviously push water at a much higher velocity. So what you end up having is there's no circuit here. There's no magic or over unity. We have a really big body of slow moving water, and we're able to create a very small body of fast moving water. That's our transformer.
Okay.
Another way to put it is engines, or let's say a motor.
Hmm.
If we had um, let's say a car had an engine that's running at a certain velocity, there might be more or less torque. If your motor is spinning faster, it might have less torque at a higher speed.
Okay. It's making sense. Okay. So
It's
then
gearing. It's gearing would be a transformer, would be
we're,
a certain ratio. So if I had a gear ratio, a gearbox that was 10 to 1, I put, 1 RPM on one side, I get 10 RPM at the other end, with 1/10 of the torque, right? But it's all symmetric. So I have low speed, high torque, high speed, low torque.
interesting.
A Tesla coil is that exact same thing. On the entry point, we have low voltage, high current, and by this gear ratio, we end up with a very high voltage at very low current.
Gotcha.
That's
And then
all. That's all the coil is.
that's able to overcome the
It's
resistance
acting in
of
totally
air, and
different ways. Yeah.
it's jumping to the bulb.
It's able to ionize air. It's able to push a lot more energy into a small point in space.
Is that what you
Hi-
call spark gap? Tesla coil to a bulb electrode. Is that a spark gap?
Uh, yeah, the gap between when you discharge it. Usually, when they say spark gap, they mean the way that the coil is powered. It's kind of like they they put a little bit of power in and it snaps all at once. Hard
Oh,
to
okay.
maybe it's kind of hard to explain. You ever see a hydraulic ram pump?
I
There's
have
a there's this
not.
old kind of there's a certain kind of pump and it doesn't really have any moving parts. Basically, there's like a flowing stream, and what it does is there's a little valve that shuts off really fast, and when it shuts off, the pressure spikes to infinity.
Huh.
It's a really weird topic,
No, but
but
it makes sense. I'm seeing it. I'm seeing it visually, and I get what you're saying.
yeah, a spark gap is usually where it has a very abrupt charge or an abrupt discharge. So it's kind of like the whip crack, where you have a slow
Interesting.
amount of input and it all cuts off at the same moment, and that
That's cool.
makes it able to deliver more energy more efficiently.
Gotcha.
But yes, tangents on tangents, wheels within wheels.
Yes.
So I think we've gone tangent enough. I think it's good to lay the groundwork where we are again. So. Uh, Griffin Brock, say a few, this was probably 2022, was he had learned glass blowing. He was using a glass blowing lathe. He was experimenting with different Tesla bulbs. He had made a carbon brush bulb. Had made a few other ones. He was trying to experiment using the original notes to build it was part of the radiant matter or radiant energy patents and bulbs. And those radiant energy, radiant matter ones, it was a very simple structure. It was basically just a bulb that had a very deep vacuum in it, beyond lower than what you can get with a normal, like an HVAC vacuum pump, and a little aluminum electrode on one end. So he was experimenting with this bulb in a one wire configuration. It had one aluminum electrode that was attached to the end of a Tesla coil, in his lab, and he was energizing it and trying to see the different properties, see what color glow comes from the bulb, see how a magnet might affect the stream, see how all, standard experimenting rigmarole. And he noticed that in the back of the room there was one of those green radiation intensifying screens was glowing a little bit when the bulb was in operation, when the discharges were going off. So it was interesting to him. So what he ended up doing was he took the screen and brought it closer to the coil and let you know the screen was lighting up pretty intensely. Of course, the next thing he does is while the bulb is in operation, he's holding the screen up in front of him. He holds his hand in front of the screen, and lo and behold, he sees his bones
Wow.
through the screen. No circuit. So he knows instantly that there's something that's being emitted by that bulb that is not conventional in any way.
It's mind blowing. Well, okay. The images I saw on the talk that you had posted,
Mm.
um, they looked focused. So, if you hold your hand up in front of a bulb against a screen, I suppose you can usually see a shadow that's pretty defined, but do you think that this is laser like light coming out of the bulb, or is it more radiant, like spreading out?
That is a good question. What the waves actually are, we're not really sure yet. So the first thing, of course, was being able to do the shadow graph, and he took a picture, saw his hand. The next obvious question or next obvious step is are these X-rays and are they dangerous? So
Right.
the next step of this journey was basically healthy level of paranoia, because if this turns out to be an X-ray tube, then cancers and all that abound.
Yeah.
So the next step was, of course, to get a couple different Geiger counters, both the electrostatic, the little digital one, and also an old, it was like the old 1950s Army different type of one. Uh, also using one of those little radiation badges that they give to power plant techs to make sure they don't go overexposure. So the next thing was basically doing different tests to see what that is, and the initial numbers were uh, incredible, or we'll say impossible, because basically what it was saying was the readings were along the lines of if you had this bulb attached to you, if these are X-rays, then you're getting approximately 5 or 10,000 chest X-rays a minute, like
Yikes.
bad, like huge. Like you're talking five. This thing's putting out 5, 10 sieverts, which if anybody knows is like basically Madame Curie would be jealous. So Griffin shared a lot of this information with us, and our initial reaction, especially when getting some of the Geiger readings and some of the range experiments, was extreme paranoia because if these are X-rays, then he's not going to live long enough to
Time to
to,
start
to
writing your
publish
will.
his he's not going to live long enough to publish his results. But lo and behold, he did some biological tests with I think the radish seeds and plants, and I think he might have Madame Curied his turtle a little bit to see if any biological effects had happened. But what it turned out is, he would leave the thing in the field, exposed to these rays point blank for 5, 10, 15 minutes, and there was no noticeable effect.
Wow.
Which, if these were X-rays, if these were conventional X-rays, uh, you would have radiation burns, you would have like hair falling out. It was like nothing would survive that. It would be completely sterilized.
I
So that
remember
was.
seeing the water, what was it? The bacteria that lives in water. He
Mhm.
confirmed, showed it living before and after, and he showed the plants and charted out the. So he didn't say anything about his turtle though. Is the turtle okay?
Oh yeah, it's running around. It,
Oh
it
my
chews on leaves.
gosh.
Yeah, there was no issues with that. And as he did more of these experiments, he became more confident that the waves were not harmful. So he was more amicable to do hands-on tests.
Can I ask, is
Pardon,
there any
pardon my
sign
pun.
that it's beneficial?
No,
No.
uh,
Okay, no sign.
no, it's really hard to find positive medical effects because the placebo effect is really hard to bypass.
There you go.
I can't say for sure. I would say it's not. I, if I was to guess, I would say it's not healthy.
Not
But I would say
healthy.
it's not. I would say it's not harmful anywhere near the scope that a conventional. If my theory is correct, then it's about 1/100th as dangerous as conventional X-rays because they're electrons and not X-rays. But that's throwing in the tangent. I'm going with the Griffin story.
But that's
So
fascinating. That your theory is that they are electrons and not X-rays. So an X-ray is a photon?
an electron beam is beta radiation, and because beta particles are so tiny, they're electrons that are smaller than atoms,
Huh.
is they're much less likely to collide with atoms, which
Okay.
means they don't cause the same type of uh, DNA damaging type stuff. They're
Okay.
more likely to pass through atoms and thus biological tissue than to damage it.
Wow.
But the tangent is we're at Griffin with his bulb, and he's by this time he's made a few more bulbs. He's made replicas, uh, seen how the bulb degrades over time. He's broken them apart, started looking at the electrode, all these little things, and we're starting to stabilize along the idea of, well, these maybe it's not X-rays is not the right term because if they're X-rays, everyone would already be dead. This Around this time was when I was invited to his lab to do some of these hands-on experiments because it was truly groundbreaking. So I had brought a few of my some of my equipment out there, and we were able to do a few more tests. Of course, knowing the numbers he was posting, my paranoia level was like, you know, full hazmat lead suit. You know, the first experiments, it was like, okay, we're gonna do a test. It's gonna be quarter second, and I'm at a far angle, behind the wall. Okay, hit
Wow.
it.
And what were you
because
holding there?
different, either maybe my hand or a lot of times it was a screen with different obstruction on it. So we were using different thicknesses of aluminum to try to shield to see how it was penetrating and how it would affect the brightness.
And taking X-ray images of your hand,
Not X-rays, but
or right,
taking
taking
chat to see it firsthand because I
shadowgraphs of
I
your
had only
hand.
seen I had only seen pictures that he was showing us. So
This is
to see it
incredible.
firsthand and also to understand it because once I get a couple bulbs on my possession, I want to, it's if only one person does it, it's just a miracle. We have to replicate this and get more people studying it and experimenting. So I wanted to know what the parameters were because does it have to be in a completely dark room? How bright does it get? What kind of transmitter, what kind of coil and power supplies do we need? So this weekend trip was to sort of answer some of those questions. And I got a little. I'm still, healthy level of paranoia has never hurt anybody, but I'm a little more confident that the waves are not harmful. But the numbers that it was so interesting that the properties that it had, the way that it would just go straight through a wall almost unimpeded. You could have a Geiger counter and you could be picking up readable signals 50 feet, 100 feet away. And yeah, pretty incredible.
Which
Uh,
does not happen with a regular X-ray machine.
if it happens with X-rays, then when you have it near uh, when you have it point blank, then your hair's falling out. You're radiation poisoning. You got to take the potassium iodide pills and things like that just to survive. It's like
Wow.
if that was X-rays, it would be or massive health effects. And at that, and to the point, we still haven't been able to reproduce any negative health effects, either in uh, plants, tissue, people willing to Madame Curie themselves, including himself.
Yep.
Uh, so anyway, that was early 2022, and I believe what continued from that was further refinements and variations, and then eventually what he did is he compiled a very long lecture in 2023 that presented at the ESTC on exactly this topic and the process that he goes through to create the bulbs, the history of Roentgen rays and X-rays, how it came in, how it was very cowboy, Wild West back then, how Tesla got involved and what he was talking about on the matter and the pictures that he posted. And of course, the culmination of it is he did the demonstration himself where he has a low light camera with an intensifying screen in darkness. And, you can see in real time waving.
Right. I still would have been nervous in being in that audience, but
It was a 3 hour lecture. I think it was only the most hardcore of us that had stuck
okay.
around to the end.
I mean, it took me a little while before I got to watching the entire video. And I was just thinking, like, if I had just walked into this room and, kind of just saw the presentation, I would still be pretty nervous for him to be turning that thing on with me, 20 feet away. But
Absolutely, but he managed it really well because, well, one, he didn't really use the word X-ray because they're not X-rays.
right,
That's a no-no word. That's like the R word, radiation.
right,
That we had to be really really confirmatory that these are not X-rays because they don't have the same effects as it.
right,
And then he also did a really good job, contextualizing everything that he was doing with all of the history and what everybody else was doing. So by the end of the lecture, it's like he had a really good foundation to where people weren't at least uh, not jumping out of their seats in surprise at what they were witnessing.
right.
Uh, any questions on that, Ben?
Um, man. Okay, so my question was, um, or at least what's going through my mind is how can we compare the way that these Roentgen rays are being produced to the way that X rays are produced? Um, and I'm thinking like, how do we know that?
How
Well,
do we know they're not?
yeah, how do we know they're not? I don't. I mean, I just assume X-rays are a type of or a frequency of photon, and so we're dealing with frequencies of electrons. Electrons, I'm from there. I'm thinking about waves and particles behaving as waves, and that's where my brain goes. So,
One thing, one thing that's clearly different is all X-ray tubes have two electrodes. They have an anode and a cathode. They bombard one with the other, and the reflection, the scattering bombardment of that interaction is what creates these waves that are X-rays. All of Griffin's tubes have one electrode, one wire. If you ask a physicist or ChatGPT or whatever, uh, X-ray tubes always have two electrodes. There are no monopolar X-ray tubes.
mm,
If there are, Griffin made a great discovery just by that sheer fact alone. Or actually,
interesting.
Tesla did. He just replicated it 100 years later.
Right. And so electricity or electricity is coming from the Tesla coil. Is that AC or DC? And it's going into a piece of aluminum. Is that to your, in your mind, do you think there's a, a static charge being packed into that aluminum until it releases something
Oh, I
or
love this. This is we're getting into the theory point,
yeah.
and you're saying almost the same as we've had in our side discussions. So Eric Dollard, Adrian Marsh, Griffin Brock, and myself, we've had multi-hour talks about this behind the scenes of, what are these? What is the theory behind how this stuff actually works? Um, we don't know for sure. There's experiments that we have, planned and some things that we have roughly done that can at least rule out certain theories. But what's interesting is, between the four of us, we have about 5 or 6 different theories of what's actually going on. I can state, how do I put it? There's a few possibilities. The one possibility I kind of like the most is that it's actually an electron beam or it's a cathode ray. What makes it unique as a cathode ray is that normally an electron gun only puts out cathode ray, electron beam, whatever, only puts out electrons at the energy level of the source. So if you put one a 1,000 volts in, you get a 1 kilo electron volt electron. If you put
Mm,
1,000,000 volts in, you get a 1 mega electron volt electron. If One explanation that does explain how you get rays that are penetrating like that would be extremely high energy electrons. Those would be high enough energy to go several feet through solid matter. Uh, the question or the problem with that theory is that to get the numbers that Griffin reaches, to get these kind of penetration values, you need an electron beam somewhere along 20 to 40 million electron volts, like 20 to 60. I forget the exact number, but at least 20 mega electron volts, which means you need a, let's say, 30 million volt potential source. And the problem with it is the Tesla coil is only about 500K, less than 1 mega.
okay.
So something's happening. Somehow you're able to get from a 500,000 volts to 30 million volts. There's something that's stepping that up by a factor of like 20 or 30 to 1. One of the theories I have is that it may actually be the Farnsworth fusor. Is that what may actually be happening? Is there some type of fusion, may or may not be the right word, but there's some type of fusion-like effect happening on the electrode or on the surface of the glass, and that effect is causing this electron to be amplified or accelerated beyond what's normally coming out of it. It's really
Wow.
crazy stuff.
Yeah, that's incredible.
Uh, Eric's interpretation is that it is a cathode ray, which is not totally different, but Eric doesn't really follow with electron theory and electron models, so it's the same but different. It's more nuanced.
Okay.
Uh, Adrian, I think one of his theories was that it might be a different form of X-ray or a coherent X-ray rather than a scattered one,
Uh-huh.
and that might have some explanation. Another
Interesting.
one is that it might be insanely high, what was it, hard X-rays, which
Uh-huh.
normally don't come up because they're much more penetrating and oddly enough less harmful. Probably the same reason why the why beta radiation is less because particle size and it doesn't interact as much. But yeah, this just to cursory off the cuff, there's those few different theories, and we have some ways that we could confirm that, but most of it is, 1,000, let's say 6 and 7 digit figure test equipment that would have to be purchased just for that test.
Uh-huh.
The way Griffin sort of handled this is he sort of outsourced a lot of that problem because what he ended up doing in the lecture and afterwards is he sells the bulbs and explains to people how it's powered and how you operate it. So what he did is, as far as I know, other people can grab the bulbs and experiment with them that might have more sophisticated apparatus or full scale test equipment like X-ray spectrometers and all this really fancy, super expensive stuff you only find in a physics lab.
Wow.
So
One test I'm thinking of is you've got your bulb here and you've got your hand here and you've got your screen here. If you have a shadow projected on the screen and the shadow is bigger than your hand, um, that that at least tells you that it's radiating outwards. If it is exactly the same size some distance away on the screen, that is very weird. Do you remember? Because then you're talking about some sort of like
I
collimated
believe it
laser or something.
scatters. I believe it scatters from the electrode surface. So about a 1 inch diameter aluminum electrode expands roughly uh, roughly linear from that point outside the bulb.
Okay.
Uh, One thing we do note is a magnet near the bulb will affect the position. It can deflect the beam inside the bulb, but once it's in free space, it either doesn't deflect or it's very hard to detect. This
Wow.
is one of those
Interesting.
things is where trying to confirm or deny what the issues are.
Huh.
Uh, Another thing we did was familiar. You might not be familiar with the cloud chamber, but this is when you
I've
have a
seen a couple
chamber
videos
filled
you
with like
posted, but otherwise,
with
no.
ammonia vape. It's basically a really, really cold chamber with a saturated liquid, and then basically whenever an energized particle goes through it, it's enough to ionize that air just enough where it creates a little cloud-like trace. So you see these little needles that come out. Depending on the size and the density and the direction of the needles, you can usually figure out what type of radiation it is.
Hmm.
We did try that experiment, but unfortunately, it was basically too big. Instead of being normally, if you put like a cloud chamber and you have a little piece of uranium or something, yeah, you'll see these little jagged bolts shooting out from it. Is the cloud chamber. When we had the radiant his radiant bulb on it, it just completely overwhelmed. So we couldn't really tell what it was. It was our apparatus basically.
It completely overwhelmed, as in just light was
It turned
shooting
into
out
a
everywhere.
well, no, like the cloud chamber just completely ionized the whole thing.
Okay.
We couldn't identify individual threads or traces to see if it was an electron or a gamma ray or something like that because there was just too many of them. It
Huh.
overwhelmed. So what we should have done is we probably should have done like a capacitor discharge or some. We would have to make some other circuit that would try to piecemeal individual flip it on and off, only let a couple pieces in at a time to
Interesting.
observe. But
Wow.
as you know, there's always more experiments than there is time to do them.
Right. Man, this is a frontier of
But
research. This is really cool.
yeah, that's the frontier. The latest update, so this was 2023, was when Griffon officially published this to the public in July. He's been selling bulbs since then. There's probably at least 100 people that have them in their possession. there's at least 10,000 people that know how to make them.
Mm-hmm.
That the information isn't exactly secret. He's been open source about this.
Mm-hmm.
Uh, the latest is basically we get little bits of information from universities or people that are experimenting with it, but I don't think we have any uh, solid leads. So we're just gonna have to keep coming in our group to come up with something. One of them is we might be able to make DIY X-ray spectrometer is one
Mm-hmm.
possibility. Gamma spectrometer, where you have these rad level detectors, but you need a single photon electron like multiplier circuits. Yeah, there's a bunch of different experiments we can do that we just haven't really gotten to yet.
Interesting. Where my mind goes, and of course, I'm completely unqualified to do this, and I will not because it sounds very dangerous. Is what if you put it inside a Fabry Perot, two mirrors and turn it into a laser? What happens then?
Indeed, what would happen then?
You
Oh,
explode the planet.
one of the tests would be to see putting a metallic surface and to try to see if you can get reflections off of it and see
Huh.
how if those reflections are any different too, because we know it puts out rays. One of the problems we have with the thing is that uh, because those bulbs have to be ran with basically a Tesla coil, which is high voltage, high frequency power supply, is that tends to overwhelm test equipment that's nearby. So it's like it would be really hard to have an electric sensor anywhere near that thing because you fire it off, you can't tell when a signal's coming from the bulb and what's coming from the power supply. It's just
Interesting.
one of those difficulties. So
Interesting.
anyway, I think that pretty much puts the Griffin story where we're at right now. So
That's really cool.
yeah, Q&A, where we go from there. I think you can still order his bulbs on the website. I'm not sure how often he gets to them or if it's backlogged, but we all get distracted with school and projects and like we said when we first started, getting to all the projects except the ones you actually want to do.
Right. Yeah, it's incredible. I'm also curious this beam that it puts out. I would be very curious about optic tests and whatnot. Because you talked about reflecting it, and that
Mm.
makes me think, okay, if it's an electron beam instead of a photon beam, what reflects a photon might not reflect an electron, but maybe there's something that is. I don't
Hmm.
know.
Another one was using different thicknesses of, we'll say, blocking material. Because one of the ways, if it's an electron beam, if it's electron, very high energy electrons coming out, then what you can do is there's a certain curve is that the twice the thickness should be half the brightness. So there should be a way that you could use different materials of similar calculated density so that on the other end it puts out the same brightness. There'd be ways that you could basically help confirm if it is an electron beam and also estimate its energy.
Interesting. That's really cool.
I think this was a good one. Maybe I guess we're just gonna have to come up with some random topics and go from there. I think these are kind of fun.
We totally should. I mean, honestly, any day we could just go on. I'd love to hear about Tesla coils. I'd love to hear about even, just starting from some of the basics, at least for myself, and
If
working up to the more advanced stuff.
for a listener that might be on here or people that are just getting started, I think one of the best ones, the best primers for all of this, would be Eric Dollard's lecture, "The History and Theory of Electricity." It's not really an engineering lecture; it's more of a history lesson, and it's where electricity came from, all the foundations and origins, and how everyone sort of figured out where they were. It was the advancement of electricity and electrical engineering from antiquity to the death of Steinmetz. It's basically until Einstein kicked in, which Eric would say that was when electrical engineering died. But
Right. That
it's
could
a
be an
really good
entire
primer.
series in and of itself, just breaking that down, you know?
Yeah, he has a few hours and really good detail on some of the different achievements and advancements, and the fact that these discoveries were made by people that were working with nothing.
Hmm.
Like Galvani, the first guy that discovered electric, I believe it was battery type stuff.
Like the
Uh, you know,
twitching frog legs and
the,
all that stuff.
yeah, this wasn't an electrical guy. This was a surgeon
Right.
dissecting a frog leg, noticing that the leg moved when he touched it, but only if it was fresh or some. A surgeon is like electrical engineer.
Right.
Uh,
And Daniel Faraday didn't have a degree himself, did he?
he was like a steam engine guy, I think, and somehow got into the electrical world.
Yep.
A lot of this stuff, it was these are the founders. There was nothing to work with.
Right.
Tesla, if you look, one of the really good ones is Tesla in his, we have the Colorado Springs notes. So it's one
Uh-huh.
of the notebooks that we found later, way after his death, that discussed his experiments in the late 1800s with, the Earth, using the Earth as a conductor.
I
Tesla,
actually did not know it was found way after his death. That's interesting.
but 1897, I believe. But this was the groundbreaking era. But there's an excerpt in his notes where he winds one of these coils, and he needs to find the inductance of one of these coils that he just wound. So the way we do it today is we have an LC meter. We put the two electrodes on, and in about half a second you get your results. Tesla spends, I believe it was about 2 days hooking the coil to different motors and different potentials and comparing frequencies and doing all this math to determine the inductance of one of these coils. Is that
Wow.
what we do in less than a second? He had to spend 2 days coming up with, because there was no LC meter.
Right. We have an incredible floor to stand on that used to be somebody else's ceiling. So,
Exactly. It's very well said.
yeah. Cool. Well, it was great talking to you. I think I'm going to let you
Likewise.
go and yeah, can't wait till
Thank,
next time.